Hello everyone. Today I am going to discuss about count the number of vowels and consonants in a list. I have opened the Prolog terminal. Today I will show you the program directly in the Prolog terminal and show you how to write the logic step by step. Now we have to open the editor. To open the editor we have to select the file from the menu option in the Prolog terminal, and then you have to select new to create a new editor. Now here I will give a name list VC count. Let us say this is our file name and a new editor will open. Here we will start writing the program. Now before writing the vowel and consonant, I need to identify all the vowel characters and I need to I need to create a knowledge base inside the Prolog editor, inside the Prolog compiler, so that when the logic will be written, it able to check whether this particular character is vowel or not. To do that, I am creating a knowledge base with vowel predicate mentioning A is a vowel, another vowel predicate mentioning E is a vowel, and so on. I will continue writing all the vowel characters. Next, I will define a predicate that will receive inputs and will give the output. And the predicate will be my name is VC underscore count. And here in the first parameter, I will take the list. Then I will take output as output variable. I will give a name as V for vowel and C for consonants. Now this first line that I wrote as a predicate to count the vowel and consonant is nothing but the base case, where if the list is empty, then my vowel will become 0, my consonant will become 0. Here instead of writing VC, I will write 0, 0, which indicates the base case of the recursive function. Next, I will continue with the logic. Now, if the list is not empty, so it will contain either sequence of vowels arranged in a random manner, or mixture of vowels consonant, or a consonant in a random manner. So what we need to do for a list to check, we already know that the head is the element from where we can take each element one by one and check whether it is required to solve our purpose or not. So here our next objective is to split the list. If list is not empty, then split the list into head and tail. Once it is done, then the second parameter will be for my vowel, where the count will be stored in the variable capital V, and for consonant the count will be stored in the capital C. Now I will be defining the rule that if my head, since it is a list, so I have to consider head each and every time. So if my head is vowel, so I will check vowel directly. Now this means that whenever a function named vowel is there, and inside the parameter my h, that is the first element of the list, will pass into this particular function or predicate, then the program flow will automatically go to the very first line of this function name. Now if h contains a, then it will become true. Then the next part of this rule will be executed. Now suppose the h is not a, it is I, then first it will check whether it is a. If not correct, it false. Then we'll go to the next vowel function, where it will check if this particular is I or not. No, it is also false. Then finally it will go here. It will check from top to bottom each and every cases until it gets a true. Now once it gets true, then the program allows to carry forward with the next part of the logic. I will recursively call this function VC count, and I will, discarding the head, I will only pass the tail part of the list, and I will give V1 here, because for a new list the count will be new, and C. Since I'm not interested with the consonant at this stage, so consonant remain as C. only the vowel get changes, because currently for this logic, for this line rule, I am interested with whether this head is vowel or not. If it is vowel, then this particular V will get incremented. Now since this V will get incremented, it is directly related with this V1. That is, if a new list or modified list or any alteration is being sent recursively, then obviously a new variable needs to be used for a new input. Now here the new input is T. Now I'm closing this VC count parenthesis, and then I will add the rest of the part. To calculate V is V1 plus 1. So this entire line representing the rule which actually responsible for counting the vowel only. Now if it is not true, if this vowel H is not true, that is the head is not a vowel, it is consonant. So what happened? We need to write another logic stating the same name of the predicate VC count. Here also we have to split in the same way, writing the variables for vowel count and consonant count, and then the rule. Now since I already know that vowel H becomes false, so for the value that has been stored inside H is not a vowel. So again, for this alternate logic where I'm trying to find out the consonant, I do not need to check whether it is a vowel or not. So I'm skipping that part. I will directly go to VC count. Discarding the head, I will only use T because I know this is consonant here. I will keep the vowel variable as it is, no change. But here in this case, the consonant variable will be different because at this line of program, we are dealing with the consonant part. So that is why with when the recursive call is happening with a updated or a new input T, in that case, C1 needs to modify it. C1 needs to, from C needs to be C1. And then C is C1 plus 1. Now this is our program logic for counting vowel and consonant if present inside a list. Now let us compile the program. Now here it is given a singleton variable warning where H is a singleton variable. Yes, it is, because at this stage H has been used to split head and tail, but H has not been used inside the body of the rule logic. That is why it is singleton. Since it is not used, we can write it as anonymous variable by using an underscore symbol. And again, if we compile it, then no further warning is there. Now here, what was our actual predicate name? VC count. So VC count, then I'm giving a list. Let us check with all the elements of the list as a vowel: A, E, I, O, U, then V, then C, then dot. Dot is must to end the query. Pressing enter, it gives me the output 50 because all the 5 elements present inside the list is a vowel, no consonant is there. Now again, repeating the same query with updated elements P, C, D, X, Y. So these 5 elements are all non-vowel, that is they are all consonants. So on pressing enter, the vowel count becomes 0, consonant count becomes 5. Now again, if I give a mixture, so change over here and change over here, so now it will give me 2 vowels and 3 consonants. So it is working perfectly fine. So the program logic and the program output seems pretty okay to observe, and the output they are giving is perfectly fine. But there is an incompleteness in the program. It is because if we again re-execute this VC underscore count and then we provide the input as AEIOU, in this case, after giving the query and dot, if I press enter, it gives the output in the first instance correctly, that is 5 and 0. But you observe that the program is not complete yet. It is not terminated. So it is actually telling me that there are some more output that Prolog wants to show us. To see more additional outputs, we need to press semicolon from our keyboard. On pressing the semicolon, you see that the count changes. So 4-1, and these erroneous counts is because of the backtracking procedure. And why the backtracking is happening? Let us go to the program logic. Now here the backtracking is happening due to no restriction to the functions. So here the function means if it is empty, then the output will be 0, 0. It is fine. Now in this case, this program will only continue with this part of the calculation if and only if vowel H satisfies. So here is a condition. There is a restriction there. So this count will be changed, will be altered, will be updated only if this vowel H allows. Vowel H is true. That is, the head element is correct. Now in this case, there is no such restriction or condition in the beginning of the logic, in the beginning of the rule where the consonant is getting updated. Now, as we know that the Prolog backtracks, Prolog has a property to backtrack to the previous portion of the calculation. So as it is not getting any restrictions, it again goes inside and it alters the value of consonant that also reflects to the vowel part. Now to rectify this problem, we can write if it is not a vowel. So not vowel. How could we write not vowel? To write a not in front of a predicate, the symbol or the syntax uses / then plus. After that, writing vowel and the parameter. Now here the parameter H is given. So here I cannot use anonymous. In place, I have replaced it with H. Now this / plus means not in respect to this particular predicate. If this predicate is false, then the entire logic will make it true. That means this portion of the logic will only get executed if it is not a vowel. If it is not a vowel, then only it becomes true and rest of the logic will get executed. So let us check if this logic is correct or not. So I have recompiled it. Let us execute with A, E, I, O, U. So pressing enter, it gives me 50. But it is not giving me dot, and termination is not also happened here. So what to do? Let us see if any alternate output is there or not. To see that, we need to press semicolon. Now after pressing semicolon, it came false because the backtracking happened and then it does not allow to get inside the logic. False, thus it displays false. This is all about counting the vowel and consonant. Try it yourself and use an additional problem statement that count the number of vowel, consonant and digits given in a same list.